Hello! Last time in our series I showed you how to achieve bidirectional communication with the Pico W and an ESP32. This time we will add a potentiometer to read values from the ESP32 to the Pico and then LED brightness. Basically we'll be doing exactly the same thing we did in our previous tutorials with the ESP32 and Pi and the Pico and Pi. This will also be accompanied by a Medium article, which I will link in the description, along with the GitHub Repo. Let's begin. So let's get started. The setup will be the same as usual. I've already covered this in previous videos, so I will instead summarize things here. First, be sure to have MicroPython installed on both modules, and make sure the AIO BLE library is installed on both. The Pico already has AIO BLE by default, but the ESP32 does not, so be sure to install it manually or through Thonny. As you can see in this case, I already have AIO BLE since MicroPython for the Pico W already supports it. And here I actually had to use manual installation since the manage packages option didn't work for me. This will happen sometimes, so I recommend trying it this way. Create a lib directory, and then here you'll have AIO BLE, and then here you'll have the main Python functions here. So install it however you want. With that in mind, let's talk about the wiring diagram first. So here is our wiring diagram. So it will look different depending on how you want to set it up, but this is just a basic setup. So we have the LED connected to the GP pin 0, or pin 1 in this case, to this leg. We have ground, which is this pin right here, which is connected here. And of course, this is optional if you're using one of these LEDs. You'll need a resistor connected here and here. However, I am using a PC style hard drive LED, which doesn't require a resistor. I just connected the pin straight to these pins right here. For the ESP32, one will go to ground, as you guys can see here. One will go to pin 13, and the other one will be power. So now, don't worry about getting these mixed up, because the only thing that'll happen if you mix them up is that, for example, if you were going from 1 to 0, it will go the other way. So it's not too hard to fix it if you do mess up. But anyways, that's really it for the wiring diagram. It's pretty much the same as you've seen in previous projects. Now let's move on to the code. So first with the Pico. Now with the Pico, as you can see here, we have our libraries. We have our built-in LED. It's connected to false. We have our with statement to open the UUIDs.json file, which I've already covered before. We have the usual same code as we've done before, all the variables that are needed for a central device. Well, actually some of these variables aren't needed, so you can delete these if you want. We have message count, this is for testing only. We have our encode and decode, where we have our blink test that I've shown you many times. This is to blink the LED when it's finally connected to the peripheral. We have the receive data task. And in this case, we are receiving data. We're simply going to print a message saying that it's received, and then show the data, and then do the message count. And then of course, it'll increment. Sleep for 0.1 seconds. Then we'll do the timeout error if we need to. And then if there's any error, we'll print that as well. We have our BLE scan as we've done as always. We have our central mode, and nothing's really changed from here. It's pretty much just the same central mode function. And then we run it here. For the ESP32 code, it's pretty much just the same as I've shown you before. Import libraries, we have our with statement. We have our LED here, our potentiometer at pin 13, our ADC, which is called attention. Then of course we have our characteristic UUIDs as we've done before. We have our interval, just like before. We define our services, just like we've done before here. And of course we have the same functions as on the Pico. We have the same LED task. Oh, and then we have our send data task. Now, the reason I put in the right characteristic is, now ignore the right characteristic because I ended up not using it anyways, because it turns out you can only use one characteristic when you're using an ESP32, especially if it's connecting to a Pico. Here we have pot value, which is pot.read, and then our message will be pot value, of course, and then we'll send it as a string, and then we'll write to that. Yes, you can do that. You can write it to this message. And then we have the same run peripheral mode as we've done before. Nothing has changed really, except we must make sure to put read characteristic, as usual. Everything's still the same, and that's it for the code. So I'm going to run 2 demos, and that should be it. So I will be back, and then we can get to the demos. Hey guys, so the demo is now running. I actually had the pins connected in the wrong way, so my bad. We're at 0, so let's move the potentiometer, and you can see the values are updating just like always. So yeah, that's my fault. I had it at pin 12 rather than pin 13, but after that it's now working. You can see I'm slowly moving it, and now it's at 4095. So demo 1 was a success. I just had the pins in the wrong place, but that's what happens sometimes. So I will end things with this demo, and I will be back for demo 2, which I will be recording using my phone. So I'll be back. Hey guys, so I have the LED on and I have the potentiometer going. I didn't show you this code, so I apologize, but it will be on GitHub. So as you can see, I forgot to show you this one. It's Pico Central PWM. I forgot to show you here. We have X as our integer, and we have decode message data. Norm is equal to max, and we have 0.0, min 1.0, and then we'll take X and divide it by 4095 because that's the value of the potentiometer at max. We'll take that value and set it equal to norm. Now, as you can see here, I have had to import Pico 0 using PWM LED, and then I set it, the PWM, to pin 0. So I apologize for not showing you the code. So let me run the demo now. You can see the LED dimming, and it should be dimming to almost 0. Now, let's take it back. And there we go. It is now back to brightness. So I apologize for not showing the code, but I will have it on GitHub as usual. So that's it for demo 2. Thank you for watching, but we are not done yet, as next time we will wrap things up by covering button control as we've done before. See you next time.